I am not feeling totally ready for this stream, but that doesn't mean I shouldn't do it. And I have a few ideas floating around in my head about a little bit of a change in approach for doing my 3D rendering of SVG with a 2D projection. So I'm going to get right into that game right now. So before I pop on over to here, which is my stylo library document, I actually do want to split off here and do a quick edit here, because I do believe this app is not, or this little preview is not working entirely because of a change I made to how was that? I thought I had put in a X3D little sample here, and so I wanted to just get rid of that for a minute. Yeah, so right here, this is what I'm talking about. This little sample here is working okay, but I'm gonna take it out of the resources here and just get rid of it so that it keeps rendering quickly instead of bogging down at all. That's all. Because I'm not interested in using that for right now anyway, so I'll just get rid of it. Okay, so this X3 DOM stuff, I'm going to go ahead and just delete it. And get rid of this. I think I accidentally deleted the cylinder call, which is not ideal, but is fine. Okay. Things are almost working. I think the grid has too many grid points on it, so it's still a little slow to calculate here. At least I think that's what happened. So let's have a look at the grid here. Let's just take, oh, we don't need the random grid. We want I'm going to clean up this file structure a little bit, and then I'm going to get to doing what I wanted to do with the 3D work. Just checking on something here. Okay. Right, so let me def grid as draw slash parametric grid 10 by 10. Oh, that's gonna fail to compile. There we go. Okay, now we have a grid that should work reasonably well for what I'm attempting here. There we go. Awesome. Okay. That'll be good enough for now. So we have no need for this. Okay. So here, this spot here, I'm going to move to here. This ends up here. There we go. Okay, so mount. This spawner thing is actually, I think what would be good is to make using to test stylo There we go. Okay. Yeah, so this is just a Scratch app. It has been this whole time. I'm just putting a little note to it here. Test stylo components, where stylo is the library here. And stylo itself is, the idea is it doesn't directly produce an app. It is the, it contains all of the logic and stuff to compile documents, and those documents themselves could be apps or could be just simple HTML files or whatever. So they're kind of separated things. Now, do they end up together at some point? I don't know. I have to figure out where to draw the exact boundary there, but that's a problem for another day for sure. Right, so let's finish organizing this out for just a second. We're going to make a little container spot here. By the way, these I do believe I can just delete. Let me, I'm going to try that. See if it breaks. Label. Okay, I'm going to leave it then. Stylo. Yeah, and this arcs, and then here we've got this is what am I testing here? 3D proto tests. Sure, that kind of makes sense. A little bit. Isometric view of a parametric surface. Theoretically, that will change here. Yes, it does. Not sure why it's taking that long. It could be quicker than that. In fact, actually, what I'm going to do is make this 16 by 16 instead. I'm going to just reduce this grid size because that does have an effect on the calculation time because it's running 16 times 16. So if I have 25 times 25, right, that is 625 grid points that it has to run through. 256 is much smaller, obviously, and so just reducing this number just does speed up the re-rendering by a little bit. The thing is, if this were running on the JVM side, it would probably be reasonably fast, or you could make it so, but I'm kind of naively running this calculation on the client side, so there are definitely ways to make all this stuff faster, but that comes later on when I know exactly, when the app is basically done and designed, and then I can figure out bottlenecks in the workflows and then optimize those parts. Until then, I don't really want to be overly concerned with it. So that's 3D proto tests, arc testing, 3D proto tests makes sense there. So stylo tests has its own spot. Here, spawner, I don't really need it, so but it is kind of a neat idea, so I wonder if I should have little interactivity ideas. Yeah, let's do this. Okay. I don't know why I have these. I want to get rid of this SVG thing, but I need to figure out where it's being used. But before I go down there, let me do this drawable, and then little tool spawner. Tangle that into the file, and we'll just move it into here. Oh, Clojure, of course. There we go. Okay, that should be okay. And then here we can just merge this header with this app here. Right. So then the app itself is just calling the components that I want to render in at the time. It's very simple. This component happens to be right here, SVG tests. So I should probably rename it, but for right now that's going to be okay as it is. No, that's incorrect. And of course it can't start with a number. Let's just do this, proto 3D tests. Perfect. Then if I go over here and mount it, it's got to be proto 3D tests. Okay, that should all work. So stylo tests and mount are fine. Drawable is where things are probably a bit messy here. Mouse handlers, draggable components. This is where labels are being used. Right. Let me see. So let me just save it with the structure changed around now. There's a compile warning there, and that is because, yes, I do have to swap the order of things here. Drawable does have to be above the spawner idea, and that should fix that. It does. That's good. Okay, so now SVG. Let me see what happens if I just delete these. Let me see if there's some issues there. Seems to be no problems, which is good. So that does mean I can move these into temp SVG. This section gets moved into right here. And it needs to be bumped down a setting there. Did I, that should be fine. Let's see if that, okay, good. So this label thing has to be replaced with text. But these draggable components, they need to be totally reworked anyway, so that'll be solved another time. Right, so we've got the top level, we've got the namespace here. That's good. Interactive ideas are there, stylo tests are here. This is what I'm working on right here. Okay, so we are in a good spot. Let's see what happens if I do this even. See, this is kind of a cool thing about this parametric grid thing. Does let me nicely kind of control the shape of the tessellation of the surfaces independently, which is pretty neat. Right, like in a perfect cylinder here, you do only really need one cell that way, and then you can make this a much bigger number and get a more refined cylinder without a crazy amount of triangles on there, right? Right, like doubling the set this way doesn't really get me anything if I know it's just going to be a base cylinder like that, right? I can just have the grid be that way. It just is cool. Let's keep this at 64 though, so that it's not a crazy huge grid there. Perfect. Okay. Right, so this is reasonably organized for right now. That'll be good enough for what I'm trying to do. And so now I do want to start thinking about well, I'm just going to get right into it. Let's, instead of making a draw namespace right here, what I actually want to do is make a namespace I'm trying to think. I want to make a namespace that is 3D stuff. It's the 3D equivalence of all the SVG elements, but I need a name for it that doesn't start with the number 3. Scalable vector graphics. Yes, yes, that's fine. I don't know what to call this. Well, okay, so let's do, I'm gonna have drawing 2D and drawing 3D. D3D. S3D, scalable 3D graphics, S3G, It's confusing. Draw is also, actually, let's just keep going with the idea that it's in the draw namespace, but let's clean this namespace up a little bit. Okay, so we have two forms of containers here, or a few forms of containers. There's figure and fig. These need to be cleaned up, but I'll clean them up. They need to be combined. We've got a drawing 2D. Which is, I'm using incorrectly right now. But let's ignore that for the time being. And let's work here on this section, which will be, actually, before I do that, let's do this. Okay, so there's this new section I'm calling, so just like I have in SVG here, I've got the SVG element. I need what I want to do is have a shapes. Yeah. So let me there's going to be a shapes. Basically what I want to do is create equivalent shapes calls here in 3D. So they're gonna basically have exactly the same setup, but just have an extra dimension on them. And then they're gonna have to be wrapped in some kind of SVG 3D container, which takes all of its content, transforms it by a default rotation of some kind, and then spits it out basically. So what's the right thing to do here? Not even sure if that makes sense. I don't even know if it makes sense to me. I'm just kind of talking out loud. And figuring it out from there. Okay. Let me think about this for a second. Well, okay, let's go load file source stylo svg.cljc. If I typed it correctly, there we go. And let's also load draw. I made a mistake. Let's go here and make a shapes call here. Okay, there. Shapes is what we're going to work on next. We're also going to work on a little thing. Actually, we need to work on two things. This one will be shapes. And this one will be the 3D element, which will be SVG 3D, I guess. Yeah, something like that. Yeah, we'll call it that for now, and we'll leave it at as is. I don't know that I love it, but it's a starting point. Okay, so this here is a problem I have to figure out. I have a Delaunay call somewhere in here, stylo.Delaunay, Delaunay triangulation, which, oh, of course does mean I should just syntax error. Oh, wait a second, that would be here. There's a syntax error, I guess, right? What would that be? Let me try to fix this. Hey Biz, how's it going? Hope you're doing okay today. Maybe I should just call it Delaunay completely here. See if that is the correct. Doing all right? I'm doing pretty good myself. I was feeling a little tired today, a little lazy is not the right word, just not feeling motivated today, but figured I'd start up a stream anyway and just kind of plug away at some work here anyway, you know? Better to do something than nothing. Man up. Hey man, I'm doing what I can. Okay, let's try load that file again. There we go. Okay. So we've got a few things working here. Triangulate surface, render triangulation. Here I'm going to split this just into its own little SCAD proto. Quick functions that create a .scad this can be used to visually check triangulated surfaces in a 3D viewer. There we go. So there's that. Here we go. This grid here is good. 3D transforms. Okay, so this 3D transform thing actually does need to be popped up here. So this SVG element here, I want to kind of create the 3D equivalent of this function. So that, does that make sense? We'll find out. And try to make something here. And so the way I'm going to do that is, what is it? Okay, so this SVG 3D thing, I'm going to try to give it the same width, height, scale, and content, and it's going to call, so what it's going to have to do is it's basically going to call, it's going to have to do something like this. Let content be some function render 3D of content, something like that. And then it'll just be call regular SVG, because you'll now have all of the 3D elements will be transformed into 2D elements at the right projection angle, basically, if that makes any sense. And then but I need so it so width, height, scale is what you call here, right? Width, height, scale of the normal SVG, and you call it with content. But I also do need to call, I need some extra parameters here, and it's what do you call that? Basically, it's the camera transform. Right, where you call render 3D with a camera transform of some kind, and you render that content there. I think that kind of makes sense. Right, so defin render 3D is going to take And then it's a work in progress, but that's the idea of that. It basically mirrors it's the same sort of setup. Oops. Mirrors the setup of the regular SVG stuff. So let me try, if I go here, SVG slash, oh right, I'm not in the draw namespace. Right, so now if I do SVG slash element shapes, there, okay, that's just the list of elements I want to try implement here. So let me go right ahead here and try. Let's do these here. We're just going to start with some simple ones. Circle, ellipse, and a line. And so the only difference I'm going to have here is I'm going to kind of create well, let's keep going with this idea. Adding in CZ here, that, I don't know if that's going to make sense, but we'll give it a shot. Right, these are basically the 3D equivalents of the 2D shapes is the idea. If we set them all up to be basically mirrors of the 2D SVG equivalents, we can get the same semantics in the 3D context and have easy, well, easy-ish sort of translation between them all. I suppose. At least that's the concept. Is it going to work that way is another thing I'm not sure of yet. X1, Y1, Z1, X2, Y2, oh, got actually a Z, X2, Y2, Z2 is going to be BZ, like that. Okay, so those, right, let's start with circle here. Right, if I do a circle of radius 5, that produces this sort of structure. Whereas if I do SVG slash circle 5, right, that produces, it's essentially identical, it just has no Z value. That's pretty straightforward. It's not that difficult. And so well, okay, so let's actually let's just follow the logic through for all of these things here. Why did I declare color element here? I don't remember why I did that, but that's okay. I am going to do G and text later because those might lead to some more frustration. But we'll start there. We'll go like this. Plunk that into the shapes right here. And we'll just go ahead and make the changes here. So as it turns out, path, polygon, and polyline, there's literally no difference because they work on lists of points in the case of polygon and polyline. And in the case of path here, it's just a wrapper function where the real value is the string for the D element here, which is built up in its own spot right here. And this should actually be SVG 3D, I guess, because that's basically what I'm trying to do, is make an equivalent SVG 3D. So that's smart. So I might realize that this is actually not a helpful way to go through all of this, but it's a starting point, and I'm gonna pursue it, see what kind of useful things fall out of it, and then change things if I need to. But that's just gonna have to be fine for right now. So this render triangulation is a good helping function for up here. I need to make this render 3D thing kind of work with whatever. So actually, I'm gonna go to the bathroom for a minute. Using the wrong mouse. All right, stepped away for a second there. Oh, hey, Artie Hiko. Sorry if I'm mispronouncing your name there. What language is this? This is a language called Clojure. Actually, I can, here, let me show you. Clojure. That's how it's spelt there. Clojure. It's a Lisp language, so it uses a lot of parentheses here, right? Maybe you're aware of all that already. I'm not sure, but yeah, the language is Clojure. If that's helpful to you. If you have other questions about it, you go right ahead and ask. Yeah. You go right ahead. Sorry if I missed you. Right. Okay, so here we go. Where was I? Oop. Right. So just Artie, let me know if you got that, I guess, or whatever. You do what you want. Okay. Right. What I'm thinking about is this concept of rendering out a shape based on the data you pass in and the camera orientation here. So this is actually going to be kind of challenging for things like circles, because well, let's see here. Let's go SVG skew transform. Let's see what we can come up with here. Okay, so I think so. The problem I'm thinking through right now is I have some prototype 3D transformations that work on lists of 3D points, right? But they don't work on that list of 3D points doesn't work on the, well, how do I say this? The circle drawing. If I draw a circle in, let's see here, right here, if I do SVG/circle radius 5 in this 3D test here, I could translate its center point in 3D, but its orientation on whatever plane doesn't make sense. I need to do something more complicated to properly orient it and skew it and everything like that. So I do need to figure out, I wonder if I can use the transformation matrix to calculate the deformation like as if it were in 3D space. But I'm not sure if that'll be straightforward to do. Pardon me. So I have to think about that a little bit. And that's kind of a challenge. It's a tough thing to think about. Let's see. I also, my head's all over the place. Okay, if I look at path, path is going to be a whole can of worms. Let's not worry about it for the time being. The focus today will be seeing if I can do anything useful with the circle and seeing if I can do anything useful with a line, because if I can do things with the circle, then I have reasonably good transformation matrix calculation, and if I can do stuff with a line, then I can do stuff with straight line paths, polygons and polylines with relative ease, which is a good thing. I also realized here I technically need to have a z value here of 0 for the 3D equivalent of a rectangle there. So that could be fine. Okay. So this okay, what I'm thinking here, I have, with this set here, what I do have is what I can do, now this might be a real long shot, but it's worth a try because it might be fun. Let's split this here. We do shapes. Oh, I'm in the wrong spot here. Ignore that. That's SVG. I want SVG 3D. Here we go. Let's pop this part open here. We'll split and make a new section here. What can I do? I need to call it something. Okay, what we're doing here is actually, so what I have is from the page here, we've got we see we see a transformation matrix which gives us an ability to define new x and y values from previous from old x and y values. I may be able to calculate the matrix from a set of new and old points, which will come from the 3D functions that I already have. So not sure if any of that makes sense, but the idea is something like this: x new equals ax, x new equals ax old, basically. Oh, no. Equals a x old. Boy, this is bad notation, but whatever. Plus c times y old plus e. I'm realizing this might not be as easy as I thought. We'll find out though. And y new is b y old plus d y old. Yeah. Oh, this is x old. Plus f. Right, so the problem I have here is, of course, I have only 2 equations, but I have 6 unknowns. So that's not good enough. Right, so how could I do that? Well, let me see if there's a way to do it. Yeah, get the transformation matrix from the points. Is that possible? Or is that easy, I guess, is more my question here. Is this an answer or not? Let's see. Yeah, so this question is along the lines of what I'm attempting to do myself. Yeah, so I wonder if there is something simple that I'm just missing. Inverse matrix. Hey, Marison, how are you? Hope you're doing well today. I'm a little quiet at the moment. I'm trying to think through a little problem I've got here. I don't know if I am going to be able to solve it easily, but that's okay. Hope you're doing well. Yeah, I'm doing okay today. I actually was feeling a little tired, a little not wanting to work, before I started the stream, but I figured, hey, may as well start it and start poking around, kind of get a bit of momentum going. So I'm feeling a little better now. A little bit better. Didn't sleep? Your cats didn't let you? Oh no. They crawling all over your bed? Keeping you awake? They were ramming into the wall and they were really loud. Oh man, cats are sometimes a problem, eh? My old roommate has a cat, and when I was still living there, he would occasionally cause some problems too. And 2 kittens. Oh man, it's kind of fun. Like, pets, I think, are nice, but every once in a while they're a bit of a handful, eh? Yeah, but my old roommate's cat would always run up the stairs, but he would wait until you were walking up them, so he'd always like trip you as you were going. It's ridiculous. I don't want to reinvent all kinds of complicated matrix math here, so they're very loud. One is a Bengal, big as a normal cat when it's fully grown. Oh man. Hey Marcel Monster, how are you? Oh, you just followed. Thanks for that. I really appreciate that. You might be used to like things popping up on the screen. Sorry, I don't have that set up at all, but regardless, thanks for the follow. I appreciate that. I think I might put this thing aside for a minute there. Oh, he doesn't speak English very well? Oh, is he a friend of yours? That's okay, by the way. Yeah, no problem. Don't feel... Oh, from your stream? Nice. Cool stuff. Anyone watching, if I'm asking you questions and you can't or don't want to respond, totally fine. No problem at all. If you can't speak in English as well very easily or with confidence, no issues at all. Thanks anyway for the follow. I find that really nice. Okay. Oh, hosting? Thanks, Marison. I appreciate that. Well, let me see if I can come up with something sort of on the right path here. Let's do a circle size of 50. What? What have I done? Oh, up here. Right, I have this should be SVG/SVG, right? Marcel, your name is Jeff. Oh, nice to meet you there, Jeff. Marison, you're playing some games now? Well, that's cool. Thanks for stopping in for a bit. Have fun. I'll see you later. Okay, there we go. All right. Let me go in, change, let's copy this. Oops. Oop. Oh yeah, of course. I've got a few things going wrong here. These are here. These actually, let me see here. Points to string. Given a list of points, does it produce the string that I expect it to produce? Okay, we have 0, 0, 0, 1, 1, 1, 2, 2, 2. Okay, so that does work the way I want, so that's theoretically fine. So saving that should work. Yeah. Okay, perfect, kinda. Okay, so this, let's comment that out there so we can see. What have I done? Oh yeah. These are just reference, so that goes like that. And this should work now. Okay. So we have circle in the wrong position. Pardon me. So what I want to do here is create let's see. Okay, so if I go here, there's this here, vrep circle function. It's just one function. If I do that, vrep circle of radius 50, I get, well, let's def that as a. So that's a function. A, if I give it 0, it gives me a point in 3D space. If I give it 1, it also gives me a point in 3D space. So if I do, well, let's go ahead and do this here. If I def circle A is going to be d/vrep circle 50, and if I def circle points, is going to be, let's see, take 3 of repeatedly random. Is that what I think it is? Let's try that. Take 3 repeatedly rand. Yeah, so then I just do map v circle A onto that list of points. That should work. So if I do here, map v A onto this, okay, good. So that does give us 3 points on the circle. So then, yeah. Okay, so that is fine there. So what I can do here is reduce here 4 point in circle points. I can draw first I have to translate by the point a svg/circle. Let's do radius 3. Okay, that should work. Incorrect. Gotta do that. That should work. Let's refresh this. Does not work. Why didn't that work? Let's see. Shouldn't it work? I thought it would. Let's find out what's going on here. Wrong number of arguments passed to map V. Oh, did I, what did I do? Here, circle points is map V, circle A. There it is. That should be correct now. There we go. Okay. Perfect. So I actually don't need it to stay random. I can just, why don't I just do this? Let's not make things tough. There we go. Okay. So those 3 points are on a circle. Now, what I can do is actually transform those points by doing, if I do a render triangulation, how does that work? Yeah, so if I, let's make this consistent here. B is this set of points. Okay, good. That's a set of points that'll work. Okay, so B now, if I do render triangulation of B, that gives me 2D, yeah, okay, so now if I do the same thing here, whoops, that's not what I meant. I need to copy that, paste that, there we go. Okay, so now these sets of points, they're going to be different because instead of circle points, I'm going to actually do for point in first of render triangulation of circle points. That should still work. Oh, this is from the draw library. Okay, that is confusing. But theoretically does work. Okay, so now the next thing to do is create let's see, circle. No, doesn't look like I have anything there. I'm thinking about how to do this. Okay, actually, what I can do is produce. Oh, I know. This is a little bit of a cheat, but I can do this if I do. Right, if I redefine circle points to be circle points 2 is going to be let's see. Range 0 to 1, step size 1, 0 or 1/100th. Is that, what is this? Does this work? What does it look like anyway? It does work. Okay, but I need it to go up to for right now, that's fine. Okay. So I need to map float onto that whole list. And then I need to map V, circle A onto that whole thing. Is that gonna work? I think so. And then here for point in circle points 2. Yeah, perfect. So it does kind of nicely. It does create that set of points around the circle. So what I can do instead there is create here is define a triangulation of circle points 2. Wait, can I? Yes, I can. I can do that by doing I need to create here. Oop. Right, so here we've got, I'm going to make a new function here that's going to basically be this function. But instead of render triangulation, it's going to be transform points. I think this will work. It's a much easier thread first points. I think this will be valid, but I don't know. I don't know for sure. A little cold today. Let's define circle points 2 to be this. Okay, it is a list of points. That's good. Now if I do transform points, circle points, does it work? It seems to. That's cool. Okay, so we can just run the function d/transform points of circle points 2. So that's the transform circle, and that does then give us the somewhat straightforward ability to produce here, say, svg/polygon xf circle points 2. Okay, I don't know if this will work. We'll find out very quickly. Appears to not be working, which is fine. We can go with that. We first let's just create. Let's get back to something we can see here. Okay. Okay. I saved it, yes. Oh, what have I done? Okay. There we go, kinda. Awesome, sort of. Sort of awesome. Right, so we can actually, or we should be able to do this, and no, it didn't work. Okay, well, let's do this. Okay, there, right? So that is a step in the right direction. That is something that appears to be a circle. Now the issue is it is not. If I inspect this element, it is not a circle at all. It's just going to be a polygon with a lot of points in it. Where am I going here? This, see? Polygon with a big old list of points. So what I would kind of like is to have it be a circle with a transformation matrix applied to it so that it's in there properly, if that makes any sense. So I have to think about how to do that. But this is a starting point. It's better than nothing. And I have to think about things. I have to be right back though. I do need to fill up my water. Back in a minute. Okay. So what I could do, thinking for a moment about this, I can get I can do this with right, x1, y1, x1 old, y1 old, and I can do it with x2, y2, like that, and then I have right, and then I can rearrange these as sets of equations to solve for each of those things. So I could do that potentially, and that'll work with a circle, and that would also work with an ellipse, I think. But it does mean I need to be able to generate these points reliably every time, and they can be any random points actually, but I just need to be able to generate them. And maybe random, they don't have to be random. I could pick ones that are easier to calculate, I think. Does that even make sense? I think it does. So the idea create a boundary rep circle function of the correct radius and center position. Get 3 points from this equation. Apply translate by adding center chords point. These 3 points are old points. Run these 3 points through transform points, which projects the points according to the orientation desired, defaults to isometric rotations, but in future can be anything when camera concept is implemented. Then these 3 points are new points. Then solve for A, B, C, D, E, F, right? Oop, shoot. Does that make sense? Yeah, I think it does. So let's rearrange just as an example for A. So A would equal x1 new minus e minus c times y1 old all divided by x1 old, right? So in a situation like this, right, I'm dependent on E and C here. Right, but I know this, and I know this, and I know this, and so on. You could just rearrange all of these into a system of equations and solve it. So I'm not going to do that now, but I think that's everything I need to be able to actually do this. I just don't want to do it right now. The other thing that does work is getting some boundary rep things sorted out and then just using polygon and path situations to get approximations of it, right? So this here, like if I do this range, instead of to 100 is just to 10, I have a low count, like I have a low res approximation of that, but you know, the higher you go, the more circular it appears without being a proper circle. I don't know. I'm not sure what the right thing is to do here. But on that note, if I line doesn't exist. Okay, let's mess around with the line idea for a moment here. If I go into shapes here and I build those all, if I do line now, I can produce a line that has a set of 3D points. So I could do 0, 0, 0 and 1, 1, 1, or 120, 230, and 100. So that gives me this data structure, and what I would like to do is draw that properly. Okay, so let me now back all this out and let me get back to this here. Let me get back to the 3D shape here for a minute. Okay, here what I'm going to do, get rid of these circle points, this cylinder and this grid and these triangles, make a proto 3D test. These are 3D surface stuff. Now here I can split a new one, and these will be proto. Oh, I made a mistake there. Proto shapes, SVG 3D shapes. And they start with the same thing. There. Okay. Right. So we've got axes, ISO, and that will be it for now. That won't work because this doesn't exist anymore. Proto 3D surface. And this here is Proto 3D shapes. And that should be empty. Good. Okay, so we just get rid of that. We'll zoom out again. Okay. Okay, so if we just close this drawer here and look at this here, working on 3D shapes, that's what I'm doing. What I want to do is make something that will nicely create this line the way I want it to. So I'm going to actually change this to be just SVG. That should work, won't it? Okay. Okay. This is a misnomer now. Drawing-2D is wrong. It doesn't make sense. I'm going to ignore it for now, but notes and issues. There. Okay, notes and issues. Let's also make another thing here. I don't know if it's smart, if it's a good idea to implement 3D shapes as one-to-one map of the SVG elements. This may be needlessly limiting. It makes more sense to develop a which can then be let me just leave it at this. Maybe needlessly limiting, but we're gonna go build out some ideas anyway. This is this 3D spot is where I do start to get my head all turned around in terms of not knowing what the best possible approach is. So I keep coming to it and getting a little bit stuck, but it's better to get stuck, walk away and come back and try to tackle it again from a different angle than to just abandon it entirely, at least in my opinion. So there is work to do. Pardon me. Okay. What's the next thing to do? let's try to create something here that's going to be basically uh-oh, did I mess something up here? Nope, we're good. Okay, this is going to basically be SVG 3D to SVG, and this will have to be well, let's make one function here. It's going to be a def multi that dispatches on the type here on the key at the front of the shape. But I'm going to define line 3D to line 2D as a prototype function. And what it is going to do right now is take a orientation function, I think is the right idea here. Okay, we have orient isometric, which is this matrix thing is whatever. Right, this is a function, right? Yes, it is a function. So, okay, that's good. Okay, so this here takes an orientation function, which is going to basically be the transformation over the points. That's all that really needs to be. Then the line element itself like this, right? And then here we let points be yeah, it's going to be 2 points, and it's going to be okay. Let me try something a little weird here, a little unorthodox perhaps. If I do line here, def A is this line. Okay, if I do last A gets me the map. If I do values of that, I get x1, y1, z1, x2, y2, z2. Well, I could also map get from A the keys x1, y1, z1. Oh, right, it would have to be map get last from A, 0, 0, 0. Right, and then these will be, yes, okay, that's what I'm going to do instead. Points is going to be this list, which is map V, get last of line, and then copy that. So here we have x1, y1, z1, z1, and then, well, I don't know why I didn't copy that, type it and then copy it, but whatever. x2, y2, z2. Okay, that is the set of points. Then, in this situation, points then just becomes, transformed points is orientation function over the points, and then line 3D to line 2D is actually, if I do svg/line, I can run that function with the transformed points, and we should be good to go. It should be as simple as that, but we'll find out. svg/line xf points. So let's see if that makes sense. Okay. Okay, it seems to work. So let's save that. So we have tangled that into the source, and we can draw it out in here in a minute. So let me give it a shot in the REPL first. If I do, so A is this line. If I do line 3D to line 2D with the function orient isometric and the line A, gives me an error there, and that's the wrong number of arguments to line, and that would probably be because I have to do apply. Is that right? Let's try that. Hey, there we go. Okay, so that seems to be working. Let's save that change. And what I'm going to do now is set it up here as a little thing to do. Okay, so right, what I can do here is close that. We have here the ability to create let's go up here and do def line A is d/line 0, 0, 0 to 200, 120, 300. Sure, that seems fine. So what we can do down here is just d/line 3D to line 2D, and what that will do is I need an orientation function, orient isometric, and take line A as the line. And here if I do svg/color hot pink, then it should, something went wrong here. Okay, that seems correct. That's good there. That's good there. Missing one there. Okay, let's see what happens here. Probably I need to refresh the page. Oh, it's not working. Oh, color is not the name of the function. It is color element. And that should work now. Almost. This orient ISO has to be d/orient ISO. Hey, there we go. That's very exciting. Okay. We do indeed have a function that appears to be working. So now what I actually want to do is, if I change the Z here to 0, this should now draw itself basically here. I think that makes sense. Okay, something's confusing. Oh, right. So this is, how do I want to do this? I do want to draw, what's the right approach here? Let's go like this. Let's do endpoint like this. So endpoint is just going to be some point. 200, 120, 250, 225. It doesn't matter. And then we change this to be endpoint, line A. So that should move. Yeah. Now here I want to do def line A x d/line 0, 0, 0, and it's going to be, oh, it won't be 0, 0, 0, actually, it will be first endpoint, yeah, 0, 0. I think that makes sense. Why is my brain not working on this right now? Come on. I want it to be starting at the X position. Yeah, this should be right. And then line A Y is the same idea, but it's here, 0, second endpoint, and then this is 0, last endpoint, A Y A Z. Okay, is this gonna make sense? Find out. X, Y, Z. Let's see. Could not read. What have I done? Yeah. Oh, these are all wrong. Right, color element doesn't work on a list of elements. I have to put them in a group tag. Still some growing pains with the library. Oops. Oh, I should also move this outside of that. Okay. what did I mess up here? Okay, I'm being silly. Okay, so we want to draw AX, we want to be just along the X axis, right? So it starts at 0, 0, 0. They all, no, they won't all start at 0, 0, 0. We do want it to start there, but we want it to end, not at the end point. What am I doing? This x1 has to be along x, so it starts at 0x. It's going to start at 0z, but it's going to start at 120, sure. But it's not going to end at the end point. I'm going to hard code that. It's going to end at 200, 120, 0. Does that make sense? Okay, that makes sense. That's a long X. That's okay, good. Good, good, good. This next one I can do along Y. This should be second end point. I'm not doing this in the most straightforward way here, but oh well. Okay. Sure. That should still work. Should make no difference. Okay. Now the second line here is still gonna have 0 y and 0, or pardon me, 0 z in both cases here. So let me start off this way. Oy, oy, oy. Okay. It is going to start at first end point 0 here. It's going to end at the same position. There we go. Now this last one is going to be starting at this position and ending at end point. And that should give us what we intend, but this needs to be called AZ. There we go. Okay. That took longer than it needed to, but that gives us a kind of good visual representation of what's happening here. So it is in fact working in 3D, which is nice. If I make this 0, that puts it on a plane there, pops it forward here, pops it forward there. Oh, see, that's interesting. That's a kind of a strange viewing angle, but that's okay. So if I make this 0, it moves it to a different plane. No, this should be just 40. And then this one, if I make it 0, it puts it on the XY plane down there. Okay, perfect. That is what I want. If I do 120, 120, 120, it's pointing directly, or it should basically be pointing, yeah, okay. Does that make sense? It kind of makes sense. Yeah, okay. Good. Good, good, good. Good, 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 good. If I do this negative, it shunts it out that way. I'm realizing something with my orientation function, actually. It's actually incorrect by a little bit here. These angles are not correct. Right, I think for these angles to actually be correct, in this situation here, 120, 120, 120, you would expect to see this dark line exactly along the axis marker there, but that's not what we see. So I'm wondering what I've done wrong. Oop. Okay, so when you zero out an angle, right, then of course you're going to get a projection. That's obviously not what you need. And in fact, I realize I'm probably adjusting the wrong thing here. I wonder if that's closer to accurate. We'll see. Error. Okay, let's go. If I make them both 45, will that be exactly what I need? Of course, I need to do this. Okay. Isometric projection here. Let's see. Yeah, so this, if you look at the cube in the top left of this diagram, you see that the lengths of all the sides are the same, and so along the green axis there, you get the line exactly lined up. My angles don't produce that result. So that's not correct. So if I do 37.5, I wonder if that's what I need. it's close. See, I don't totally love just guessing at those rotations. 35.264. Well, let's try that number. And have a look. Oop, not what I wanted. This is what I wanted. Save that. Save that. Refresh this. Save this. That's the one. Okay, so let me put a little note here. Euler angles adjusted according to Wikipedia page. Isometric projection page. Precise value for the first rotation is what do I have here? Arc sine 1 over root 3. Arc sine of 1 over square root 3. Let me check that actually. We've got math slash a sine, right? Yeah. Of 1 over math slash square root of 3. And that is geom slash 2 degree. Let's do math slash 2 degrees of that answer, 35.26438. Okay. We'll call that pretty good. Well, that's pretty nice. Okay, so the magic angle. This is a total deviation, but let me see here. Magic angle. Polynomial stuff. Oh, okay. Yeah, that actually makes sense. Yeah, okay. So that you could actually calculate the magic angle of a volume relatively easily using, if you know all of the side lengths of the cube or the volume, you can just use progressive calculations of the quadratic, or like a squared plus b squared equals c squared, and you just keep, Pythagorean theorem is what I'm thinking of, and you just keep figuring it out and you can get to it. Anyway, that's pretty cool. It's pretty not what I need right now, and I actually have to check something once again. It's a busy day for me, sorry. Okay. What needs doing? Actually, let me I am just thinking about what might be some good next steps, and I don't have an answer in my brain yet. There we go. Okay, that at least is really nice as a to know that the isometric projection is actually working correctly now is good. I'm happy with that. Cool. I'm thinking about what I want to do next. Let's start building out an example, or let's do def multi, and the def multi, we're gonna, like all the other ones I've done in this code base, we're gonna dispatch on the key from the element, and so we can actually use, as an example, something like the translate element function, right? So we can copy these here, bring them out, bring them down to here, and we call this shape 3D to shape 2D. No, we're gonna do SVG 3D to SVG. It's gonna be okay for the time being. That'll work. Just that will be okay. So what we have here is the dispatch function. Yeah, so let's recreate the idea of the line 3D here. Right, so what I can do is Right, yeah. I've got what I need to do here. SVG 3D to SVG. For the line element, this dispatch function works no problem, or it should, right? It ignores the first argument you pass into the function here, and then the second argument is the element, and you dispatch based on the key that is always in the first position of the element. So you pull first, it'll say line, and then it matches with this. Then here, you're going to have passed in the orientation function, which the name probably should change. OXF orientation. CXF camera transform function. Let's leave a note here. Sure, good enough for now. So that's that, and then K in props is just the destructuring of the element itself. So K new props is what's returned, which is fine. And new props is actually going to be the two-dimensional version of the properties. So what that means is SVG/string to transform map. Okay, that should be fine, I think. Yeah, so we should be in a situation where I actually don't think we'll need this. For right now, we'll leave it simple. How about that? That makes sense to me. We're gonna have points can be this whole thing, which should be the same idea. Points is that, but instead of line here, you've got you actually just have props get from props, yeah, get from props here. So that creates the 2 points for the line. The new transform is not what I need to look at. The new props is something that is important. But what I actually have to do first here is transform points as with by running CXF on the set of points, which will produce a new set of points. And then new props is, in this case, how did I do this here? xf points is the orientation function, and then well, let's leave it, let's not overcomplicate this. Let's leave it as simple as I could make it. Then here, I don't even really, destructuring it this way doesn't really matter, but that's okay. So we can just do apply svg/line to xf points. And that will theoretically get us the same result that we want. Let's try this out. Okay, so what I should be able to do, saved that. This here, if I go back to the element here, I should be able to swap this function call with svg3d to svg and save that. It'll give an error, or it won't work, but it should work when I refresh, and it does appear to be working now. So, and then I should be able to make the same change in this spot here. Okay, that should work. Just to check again. Yeah. Yeah. Beautiful. I love it. Okay, that is working. Okay, so we've got a nice starting point here for creating 3D to 2D scenarios. And what is nice is you can actually use this to create if instead of orient ISO, I wanted to do orient, let's say XY. Let's create an XY function here. So what we can do is make front, top, and right, like we can make different camera views quite easily without changing the 3D data itself. It just calculates the projection of it on your behalf, basically. So let's see. Here we've got some functions, and what we can do is just let's do orient XY, set of points. All we have to do is thread the points through a rotation. And the rotation is just going to be how do I do this? 0, 0, 0. It's going to be nothing, right? Basically, it's just going to return points. Does that make sense? Well, let's see. I mean, may as well give it a try, right? There's no. So if I orient XY and I give it a set of points, 0, 0, 0, 1, 1, 1, it changes nothing, which is exactly what I wanted. And if I do orient isometric, it does give me, these are still 3D points, which is fine. If I call svg/line, so the 2D variant of this, with 3D points, it just ignores the Z value. Okay, so that's probably something I need to make explicit with some spec calls and stuff like that. That's something to work on. If I orient XY, or ISO for that matter, a set of 2D points, will this fail? I think it might. Yeah. Right, so notes and issues, orientation, camera transform functions currently fail with 2D point sets. Just leave it at that, because probably I want to figure out if you run the 3D to 2D situation on a set of existing 2D points, it will fail currently, but you could have it have defined behavior, right? Where if you give a thing, if you give a full set of 2D things, but you want to orient it in the 3D plane, that's theoretically fine, right? It's still a drawing. You're just moving your camera basically to look at it differently. So I want it to be valid for those situations. So what I could do is always pad every point with a 0, and it should still work, because it'll just, if it's given a 3, it'll pad it to 4, a 4D point, but just ignore the 4th dimension point. But if it's 2, it'll pad it up to 3. That's probably not the smartest approach, but then you don't have any branching. Anyway, doesn't matter right now. It's actually not the orientation part, it's the rotate function here. And in fact, it's here. It's right here, where you could do the way the rotation, it rotates about a 3D point already, so you do need to pass in a Z value. So you could have it check it here, or you could have it check it wherever that gets called, which could easily be here. So somewhere in here I need to have it properly pad 2D points into 3D so that there's never a problem. Okay, where was I? Right, orient XY. Obviously, the problem here is that this function, I need it to do it to a whole scene of things. I don't want to call it like this. I don't ever want to run it on all these things independently, because it needs the same orientation applied. Otherwise, things will look super weird. Right, like even, so these isometric axes, I have to change it out for the 2D, yeah, so now that's right. But obviously I want that, I don't want to manually have to change all that stuff. I want it all wrapped up into a nice drawing 3D or something like that, like a singular function that handles all of that hard work on my behalf. That's what I need. But on that note, I'm gonna get going today. I'm just not feeling ready to tackle all of this in one go. My thinking is a little sloppy right now. I'm a little tired. So instead of pushing through and making a bunch of bad code, I'm going to step away, take a break, maybe hit it tonight on my own a little bit, and then get back to things again tomorrow. So anyone watching now, thank you. I appreciate that a lot. Anyone who happens to be watching this after the fact, also a big thanks. Please like, subscribe, comment, follow. All of those things are important because I want to keep doing this. I really enjoy it. Even on a day like today, I'm a little tired, a little slower and all that. It's a lot of fun to do. And I want to grow my capabilities at programming and streaming and CAD design, but I want to grow a community around that development as well. So if you hear this at all and you feel compelled, it's really helpful if you can do the follow stuff and share it around with friends who might be interested as well. Keywords are programmatic CAD, Lisp, Clojure, all that kind of stuff. Anyway, I'm jabbering on. I'm going to get going. Thanks so much. I will be back tomorrow. And I hope everyone has a good one. Goodbye.